The web is noisy. A web page typically contains a mixture of many kinds of information, such as contents, advertisement, navigation panels, and copyright notices. The web consists of surface web and the deep web. The surface web, these are pages that can be browsed using a browser. The deep web, these are databases that can only be accessed through parameterized query interfaces. Right. The web is also about services. Many websites and pages enable people to perform operations with input parameters, such as providing remote services, not my web service. The web is dynamic. Information on the web changes constantly. Keeping up with the changes and monitoring the changes are important issues. Above all, the web is visual. It's a visual society. It is not only about data, information and services, but also about interactions among people, organizations, and automated systems. So, what is web mining analytics? That is the process of extracting useful insights from raw data. You have said it in your introductions. You want to draw meaning from raw data. What decisions can we recommend based on data? Web mining is challenging because we have volume. There are large amounts of data at rest. You see, there is velocity. Data is increasing at a very large speed, very large rates, enormous speeds. And then there is variety. Data is in many different forms. So this is why web mining analytics is challenging. So web mining in general consists of web usage mining, web structure mining, and web content mining. Web usage mining involves the discovery of user access patterns from web usage logs. Web structure mining involves the discovery of useful knowledge from the structure of hyperlinks. Web content mining entails mining instruction and integration of useful data and knowledge from web page contents. Right. I think that brings to end my introduction. We now break for about 5 minutes. Or I think let's just continue then break afterwards. Just a moment, okay? It's up now. So let's continue. I repeat, web mining, this is the process of extracting information from the internet to identify patterns, trends, and useful data that would allow the business to take the data-driven decisions from huge sets of data. Web mining is extracting useful and relevant insights from large data sets. We need to identify patterns, trends, and relationships. So this is the taxonomy of web mining. So right at the top, we have web mining. And under web mining, we have web content mining. Under web content mining, we have web page content mining and search result mining. Then under web mining again, at the top there, we've got web structure mining. Then we have web usage mining, where, yes, there is a end there. Nyeve, fortunate for you want to say something?
Yes, sir, your my screen is blank.
Screen is blank. Others, can you see the slides?
Okay, it has just come up. Maybe it was my network.
Your network. All right. Thank you so much for that. Mind that to farmers. Who's it? I replay the video because I'm recording. Right. Then we have got under web mining. We have web usage mining, general access pattern tracking, and customized usage tracking. Right? Can we bend this into our heads? Somebody to summarize what is web mining? You see, there's a matter of it's very, very easy and straightforward. Right. Somebody to give us a summary. What is web mining analytics? Any volunteer? Right. What are the different classes of web mining? All right. You are quiet. So when you remain quiet, what it means is more work. So today you have earned an assignment, a very long one, because there's no one who can participate like this. If you choose to remain quiet, that means more work, because I want to be sure that my students really understood the concept. So instead, when they keep quiet, I give them assignments, I give them more tests. So what it means is, by the time we finish, every day you get an assignment. So today I'm going to give you about 6 questions. That's part of your assignments, because my it's okay. It's okay. It's okay. But I want you to be very, very, very active. And it is because you screen my classes my screen. But one design first trouble zvipinde musoro. And like web mining, we now know that there is web content, web structure, and web usage. Those 3. That's what we are going to be talking of throughout the rest of this course. All right, thank you so much for that. But still, we are going to get the assignment anyway.
We can answer.
That's fine. That's fine. It's okay. So let's proceed. Yes, there is a response from Karati. Web mining is the process of drawing sites from raw data. Yes, that's correct. Thank you for that. But still, the assignment is coming. Right. Let's proceed. Web content mining. We are extracting and integrating useful data, information, and knowledge from web page contents. It is the process of extracting knowledge from documents and content descriptions. Then web structure mining is obtaining knowledge from the organization of the web and the links between the web pages. It is the discovery of useful knowledge from the structure of hyperlinks. The web structure mining can be used to discover the link structure of a hyperlink. It is used to identify web pages that are either linked by information or a direct link connection. The purpose of structure mining is to produce the structural summary of the website and web pages. You will see the importance of these things. Example, a web structure mining can be very useful to companies to determine the connection between two commercial websites. You want to introduce a product. Why not? You want to check the prices, what others are charging, so you can compare, right? Even the design to look out, you can also compare based on the web structure mining, right? Then web usage mining, the discovery of user access patterns from web usage logs. Web usage mining is used for mining the web log records, the access information of web pages, and helps to discover the user access patterns of web pages. The web server registers a web log entry for every web page. So the computer that hosts the website, and we call it the web server. And we are saying when you visit www.google.com, www.google.com is a computer, right? But this is the human readable name, www.google.com. That's the human readable, but behind it, there is a number or the IP address. And it's that computer has got a number, a public IP address. And so the computer which contains the pages, we call it a web server. So the web server is the one that registers the web log entry for every page. So we are recording, we are logging. Could Indiana access a page, what information you access, and so on. Then we store that information in a file. And so we then apply web usage mining and to extract data to draw meaningful insights from the log files, information that log out. And that's what we do. Analysis of similarities in web log records can be useful to identify the potential customers for e-commerce companies. So web structure mining, under it we have link mining. So we have got link based classification, link based class analysis, link types, link length, and link cardinality. These are the things we are going to understand as we progress forward with our lectures, right? Mining techniques. What are the common web mining techniques? We have number one, classification. Classification involves identifications of patterns in data and labeling of data into predefined classes or categories. So you understand it better when we move on to practicals. Remember, this is a hands-on course. So it's the theory part first, then we move on to practicals. Classification is the process of assigning a given data point to a category. Classification algorithms are used to build predictive models that can be used. Classification algorithms are used to build predictive models that can be used to classify new data based on their features. These algorithms use training data to learn patterns and relationships between the features and the classes, and then apply the learned patterns to classify raw data. So we have a testing data set, classification algorithm, unseen data, classification feature, or unnamed objects to a class. This technique, classification, is commonly used in fraud detection. Classification is commonly used in fraud detection. You want to classify a transaction as either fraudulent or non-fraudulent. So we can use classification to solve, to detect fraud. Customer segmentation. spam filtering, risk assessment. I'm glad there is somebody who is from risk assessment, and sentiment analysis. For example, a bank can use a classification to identify fraudulent transaction based on a set of predefined attributes such as the transaction amount, location, and time. I've already alluded to that. We move on to the second type of mining technique. It is called clustering. This a technique in web mining that involves grouping similar data points together into clusters or groups. The aim is to identify patterns and similarities in the data without prior knowledge of the structure of the data or the classification of the data points. Clustering can be used in a wide range of applications, including marketing, segmentation, image processing, anomaly detection. There are various clustering algorithms available, but the most common ones include K-means clustering, hierarchical clustering, and density-based clustering. The quality of a clustering result depends on several factors, including the choice of the algorithm, the similarity measure used, and the number of clusters chosen. One common evaluation metric for clustering is the Ashworth coefficient, which measures the quality of clustering based on how well separated the clusters are and how tightly the data points are grouped within each cluster. For example, a retailer can use clustering to group customers based on their purchasing behavior and demographic information to create targeted marketing campaigns. That is straightforward. Let's move on. Another technique in web mining is called regression. Regression is a statistical technique used in data mining to establish a relationship between a dependent variable and one or more independent variables. The goal of regression analysis is to build a model that can be used to predict the value of the dependent variable based on the values of the independent variables. The dependent variable is also known as the response variable, and the independent variables are also known as predictor variables or features. In simple linear regression, there is only one independent variable, and the relationship between the dependent and independent variable is assumed to be linear. In multiple linear regression, there are more than one independent variable, and the relation between the dependent and the independent variable is assumed to be linear as well. If we compare the two, there are two main uses for multiple regression analysis. The first is to determine the dependent variable based on the multiple independent variables. For example, you may be interested in determining what a crop yield will be based on temperature, rainfall, and other independent variables. So using regression, the Minister of Agriculture can easily predict that we are going to get in the year 2024. And regression can easily do that. You can predict. The second is to determine how strong the relationship is between each variable. For example, you may be interested in knowing a crop yield, how a crop yield will change if rainfall increases or temperature decreases. If we add irrigation, are we going to improve our yield? Right? If we introduce greenhouses so that we control temperature, how is that going to affect our use? So we can easily make predictions. And not, can you do this? Can you do this? Can you foster this policy? It can be easily done using regression. Further, there are other types of regression techniques as well, such as logistic regression, which is used when the dependent variable is categorical. And linear regression, which is used when the relationship between the dependent and the independent variable is nonlinear. Fundamentally, regression analysis technique is commonly used in demand forecasting, price optimization, trend analysis, association rule mining, and association rule mining. So let's move on to the second. Sorry, I made a mistake. I withdraw the last one, dotted number 4. And so the statement should actually read: fundamentally, regression analysis technique is commonly used in demand forecasting, price optimization, and trend analysis. Now we move on to the next technique in web mining. We now have association rule mining. Association rule mining is used to identify patterns or associations among variables in a large data set. Here, the goal of association rule mining is to discover interesting and meaningful relationships between variables that can be used to make informed decisions. Association rule mining works by examining the frequency of co-occurrence of variables in a data set, and then identifying the patterns or rules that occur most frequently. These rules consist of a set of antecedents, the left-hand side variables, and a set of consequent, the right-hand side of variables. The antecedent variables are the conditions or events that precede the consequent variables, and the consequent variables are the events or outcomes that follow the antecedent variables. Association rule mining is typically used in market basket analysis, where the goal is to identify patterns of occurrence of products in a customer transaction. For example, a retailer might use association rule mining to identify that customers who buy bread, they also tend to buy milk, and therefore place these products near each other in the store to encourage cross-selling. If you get into TM store, into OK supermarket, you realize that those products, they are not just there because they have to be there. Association rule mining has been used in order to place milk near bread. Okay, let's move on. Right. So what are the, let's do a recap. What are the common techniques in web mining? Let's hear from you, class. One, we have association rule mining. What else do we have? Yes, Tenda? You can even type on the public chat. There's classification. Thank you, Makarati. Tenda, say something.
Regression.
Thank you so much. What else? Regression, yes. Yes, regression. There's another one.
Clustering.
Yes, clustering. There's another one. Classification, yes, mentioned by Makara. Thank you so much, class. Let's proceed. So, what are the web mining tools and algorithms? For web mining content, you have these tools that you can use. Screencraper, if you go on Google, just Google Screencraper, there's Mozenda, there's a web content extractor, a rapid miner, and these are the algorithms that fall under web content mining: decision trees, naive Bayes, support vector machines, and neural networks. There is also web structure mining. Under web structure mining, we have the link viewer and the Google PRI checker. And those are the algorithms, you can see them: page rank algorithm, distance rank algorithm, weighted page rank algorithm. This is also very, very important. I think you see the importance of this as we do our practicals. Then web usage mining, we have the a priori algorithm, the Markov chains, the FP growth. We have the self-organized maps and the graph partition and many, many others. So I'm going to share with you these slides so that the text that is not visible, you can always see it when you open your slide. That brings to the end our introductory part. I hope people are not confused. These are the basics. Now we break. Just a moment, just 1 minute. Just remain the next snitchy. I think we can move on to our practicals. Be thou doers of the word, not only hearers. So we have gone through enough of theory. So I think we can have our first practical. Then after that, to continue theory, practical, theory, practical. Right, Mr. Chikondoa, what time can we give ourselves before we move on, continue?
I think we can continue. Let me take presenter rights from you.
Okay, so nice. Someone put some so.
Okay.
Quarter past. I think we can break. I need to fast.
It's okay.
Class, I think let's adjourn and get 20. This is 10:15. Let's break, then come back at 10:30. And it. All right.
Correct.
Okay.